This is the second part of the 13.6, 13.7 video on right triangle trigonometry. This video is going to focus on what we call the inverse trig functions, which are what we use to find missing angle measures. So everything we did in the first video was focused on those sides and finding missing sides. Now we're going to talk about what happens if we're trying to find the angle involved with these trig functions as well. So to get started here, we're just going to start with a quick definition here. The inverse trig functions are used to find missing angles. And the reason we put that in here is the fact that as soon as you see the fact that you're trying to find a missing angle, it needs to register in your head that you need to use some sort of inverse at some point. And that goes for all of trigonometry. As soon as I know I'm trying to find an angle measure, there has to be an inverse in there somewhere. So let's talk about the way these work. And you're going to see that once I write the first one, you're going to kind of figure out what the other ones are going to be as well. But for sine, this is going to say that if sine of an angle, which I'm going to call theta, is equal to the opposite over the hypotenuse, or O over H, comma, then the inverse sine, which we indicate with a little -1 after the last letter there, of the fraction, so now the fraction goes on the inside, will equal the angle. So that fraction on the inside means that's going to be what I type in the parentheses on my calculator, and when I hit enter, I'll get the angle. Same thing is going to work for cosine. If cosine of theta is equal to A over H, then the inverse cosine, or cosine with a -1 at the end, of my A over H is going to equal my angle. Okay, and same thing for the last one here with tangent. If tangent of our angle is equal to O over A, opposite over adjacent, then the inverse of tangent of O over A is equal to theta. Okay, now that's all fine and dandy. That's kind of the very basic bones of what's going to happen here is we're going to take the inverse of the fraction instead of the actual trig function of the angle. Okay, and that switch allows us to find that missing angle, but we still have to make sure we're very careful about how we do that. So let's go through a couple problems here. We're going to start with number 7 here. 7, we're going to, for A, we're trying to find X. We're going to find X for B too. But we're starting with this angle down here in the bottom right. Okay, this is my reference angle. That's the angle that I'm working with. So that's going to determine my sides. Now I do have a 90-degree angle here. It's not marked, but we do know that that's 90. So I need to figure out what sides I have. Let's start with the 21. That's across from the 90 degrees, which means that this is my hypotenuse. And then the other side here is going to be next to my angle, so that's my adjacent, which means I'm using H and A, or A and H, which means I'm using cosine. So what I'm going to do is I'm going to set up the regular trig function. So it's going to be cosine of my angle, which I don't know. I could either use theta, or in this case they told me it's X, so I'm going to put X in there. That is going to equal my fraction using my side. So here's A over H, which is going to be the 14 over 21. So this is going to be 14 over 21. Excuse me. Now, that's my full setup. Now I need to actually solve for X. The way I do that is I have to get rid of this cosine. Now that cosine is a full function. It's kind of like a square root. I can't just divide by it or something like that. I have to do the opposite of it. The opposite is taking the inverse. So that's what I need to do. So what I'm going to do is I'm going to switch to now the inverse of cosine. So cosine with a -1. And now my fraction that I was equal to now goes on the inside. And I'm going to set it equal to X. So now my angle is on the outside to where I can actually solve for it. And X is by itself. So if I can type in this inverse cosine piece, I'm going to have my X. So I'm going to grab my calculator here, and we need to see if we can find that inverse cosine. Well, if you look at your calculator, there's actually some hints right on here. If I go to cosine, right above it, I have a cosine with a -1. It's just in blue. So I have to hit second first, then that cosine value, and now I got the inverse cosine. I'll type in 14 divided by 21. Make sure you close the parenthesis after that fraction is finished. Then you hit enter, and I get my answer of 48.189, or what I'm going to call 48 degrees. Okay, for most of our angle measures, we are going to round just to the nearest degree. With angle measures, those degrees are pretty specific already, so going from 48 to 48.1 doesn't tell us very much. So we'll just stick to whole numbers. Okay, one quick thing here, again, you do need to be in degree mode, okay, otherwise you're not going to get that answer. If you're not sure what I mean by that, go back and watch the first part. We talked about it more in that video. So that's your first problem. Okay, 48 degrees is your answer. Let's talk about part B here. So for part B, I have another missing angle X that I'm trying to find. Now this one is over here on the bottom left, but I can still figure out what sides I have and what trig function I'm going to need to use. So I have across from my angle here, the 8, which is opposite, so that's my O. And then I also have the side that's next to it here, which is going to be my adjacent. Now I'm not going to use the hypotenuse because I don't know anything about it. There's no reason to try and find it or anything like that. So I have O and A. Let's go ahead and use those. So O and A is going to be tangent, so I'm using tangent of my angle, which is X, is going to equal 8 divided by 15. I can then take the inverse of that to solve for X. So I'm going to take tangent to the -1 of 8 over 15. So the inverse of the fraction is equal to my angle. My angle is X, so if I can type that in, I will have my answer. So I'm going to do second tangent, gives me my inverse there. Same thing for sine. If you need inverse sine, do second sine. I can type that in, and then I'm going to do, in parentheses, 8 divided by 15. Hit enter, and I get my answer of 28.07, or again, we're just going to go to the nearest whole number, so 28 degrees. And that is my answer. Okay, so pretty straightforward there in kind of how we're doing these, but you just got to be careful to use the correct trig function and get your fractions set up the correct way. Let's go ahead and look at number 8 here. Number 8 is a little bit interesting. I need to find all the missing angles in the triangle below, specifically angles D and F. Angle E, technically, I guess I could say is 90 degrees, but it's marked, so we're not too concerned about that one. I'm more concerned about D and F. So let's start with D. Okay, angle D is the angle right here. Now, the weird thing about this one is I actually know all 3 sides. So by knowing all 3 sides, I now get a choice. I can choose to use any of my trig functions, but I have to use whichever one I have in the sides that correspond with it. So once I choose, that kind of tells me what sides to use. So we haven't used sine yet, so let's go ahead and use sine. I'm going to say that sine of the angle D, or I can put theta in there to hold the place, is going to equal, well, sine is O over H. So I need to find the opposite in the hypotenuse. So opposite is going to be the 5. My hypotenuse is the 13. So this is going to be the sine of 5 divided by 13. So let's go ahead and take the inverse of that. The inverse sine of 5 divided by 13 will give me the angle D. So I'm going to grab my calculator here, type inverse sine of 5 divided by 13, hit enter, and I get 22.6, or what we're going to call 23 degrees. Okay, and then the last one, and you can use any other trig function here as well. You'll still get the same answer. Let's go to angle F. I'm going to switch to a different color here. Let's look at angle F up here on the top. Can't really see the difference in that color. Let's try a different one. Angle F up here at the top. Okay, we need to, again, pick a trig function. Doesn't matter which one. I like tangents. Don't ask me why. I like tangent. We'll use tangent here. Okay, tangent of F is going to equal, tangent is opposite and adjacent, so I'm going across. My opposite is the 12. My adjacent is the 5. So this is going to be the tangent of 12 over 5. Which is a little bit weird. That's the first time we've had a fraction with a bigger number on top, but that's fine. It does happen sometimes. But I can take the inverse of that. 12 over 5 is going to equal angle F. Grab my calculator here, do inverse tangent of 12 divided by 5, close parenthesis, and you get 67.38, okay, which we're going to call, let's say, 67 degrees. Okay, and there is my answer. Now, some of you are probably screaming at your screen right now, why did you just do all that extra work? There was a lot shorter way to do that, which is correct. Okay, once I knew the angle at 23 degrees and I knew my 90, we know that all these angles need to add up to be 180, so I could have subtracted to find the 67. Okay, the reason I didn't is we're in a trig section. We should be using our trig. So I just wanted to show you that even if we didn't see that fact and did go through with the trigonometry, you could still see that. Okay, last question here. Number 9, we want to find the measure of each angle to the nearest degree. Now, this one's a little bit weird. I'm set up with my trig function in angle, and then it's equal to just this decimal. What I want you to think of this decimal as is it's the fraction that's been divided out. So they've just already divided out the fraction for us. So what we need to do is figure out the angle. So to do that for each one of these, I need to take the inverse. So I'm going to take the inverse cosine of that decimal now, which again is in the place of the fraction, is equal to my angle. If I can find that, I'll have my answer. So I'm going to do inverse cosine of 0.914, Hit enter, and I get 23.9, which I'm going to call 24 degrees. We can undo the same thing with part B, which is going to be an inverse sine of 0.829 is equal to theta. And I can do that. Inverse sine of 0.829 gives me 55.9 or 56 degrees. And finally, last one here, I'll do the inverse tangent of 4.705. Pretty big number there, considering what we have, but still works out. Inverse tangent, sorry, make sure you get the inverse of 4.705. Hit enter, and we get an answer there for theta being about 78 degrees. Okay, so these ones where I ask you to find that nearest degree are pretty straightforward. You're really just typing them into your calculator. You don't even have to figure out what trig function you need because I'm already giving it to you. Okay, so that finishes up the rest of our notes for 13.6, 13.7. If you have any questions, please feel free to reach out to me either by email or talking to me, and we'll get you all squared away with these notes.